Up to this point, we've looked at programming custom nodes in ROS with hard-coded values, like what string to publish or how long to wait between timer function calls. The good news is that we do not need to rely on hard-coded values in our nodes. ROS 2 implements parameters that let us set values at runtime. This means we can reuse our nodes for different purposes or tweak values in our robot. By now, you should be fairly comfortable writing custom nodes and working with topics and services. In this episode, we will explore ROS parameters so you can configure nodes at runtime. Let's see how that works. If you head to the documentation for your particular distribution of ROS, go into API, and you should see a bunch of the API contents. Scroll down, you can find parameters. This talks about how to declare and use parameters in your particular node. As you can see, there's not a whole lot here. Parameters are fairly straightforward, but there's a couple of gotchas that I want to demonstrate. First, let's see how to declare them and use them at boot time, or when you first start up your node. Let's go into our container here. We're going to go to VS Code for ROS 2. I'm going to close down this terminal. Let's go into my PyPackage for the source code. And we're going to start with minimal publisher. I'm going to right click, copy that. I'm going to paste that. I'm going to rename it to publisher with params. So in here, we're going to make a few modifications. The first is we're going to change our node name. We're going to call it publisher with params. Everything else basically stays the same. We're just going to periodically send out a string. We're going to change the name of that node to publisher with params using snake case this time. We're going to get rid of counter. We're not going to actually use that here. So let's get rid of counter. And we're going to change this data in a moment. So after we call the superclass constructor, we can declare our parameters. This just says that, hey, a particular parameter exists, and we can set a default value here. No assignment is being done to anything in code yet. So we're going to say self.declare parameter, and then we're going to give the parameter a name. I'm going to say the parameter's name is message, and then I'm going to set a default value. I'm going to use the string hello to start. Note that the ROS backend looks at this parameter type and uses that to determine what type of parameter is being declared. So hello is a string, therefore the message parameter should be a string. That's how it knows. And you can always set it to something like an empty string here. Let's declare another parameter. This one's called timer period, and we're going to set it to 1.0, so a floating point value. This will be the number of seconds between timer callbacks and how often we publish that string to the topic. Then we're going to actually get the parameter values. To do that, we need to call the getParameter, which is also in the node class. And we're going to give it the name of the parameter we want to access, in this case, message. Note that self.getParameter returns an object. That object wraps up the value. So right now we're setting self._message, that private variable, to a particular object, not a value. So to get the value, we need to actually access the value attribute in that parameter object and set it to the member attribute that we actually want to store that value. And we're going to say self.getParameter, the name of that parameter, which is timer period. Note that it matches up to the one we declared earlier. And then .value to get the actual value. We're going to create a publisher object as we did before. This stays exactly the same. But we are going to change this create timer and how often that's called. So instead of hard coding this 0.5, we're going to use timer period. And so this doesn't cross this 80 character line here. I'm going to separate these arguments being passed in. So we no longer have a timer period that's hard coded. That's getting pulled in from this parameter. Let's go down to timer callback. We're going to still fill out that same string message, but instead of this hard-coded message, we're going to use that message member attribute we set earlier. This still publishes the same message that we've constructed up here, and we're just going to log it to the console. The last thing we need to do is change this minimal publisher to our actual node name or our class name, which is publisher with params. Don't forget to save that with Control S. I'm going to go to setup.py, and let's add the executable here. So I will say publisher with params equals my PyPackage.publisher with params :main. That's that entry point. I'm going to end it with a comma so it's easy to add the next one. Control S to save. Let's go to terminal. Nope, let's go to view terminal, bring up the terminal we've been working with. I'm going to say callcon build -- packages -- select, and then mypy package to tell it to build just this Python package we've been working in. Once that finishes, you can click to exit out of that pop-up. Looks like we have no errors. Let's go over to our run desktop. We're going to bring up a console here. We're going to go into our config workspace. We're going to say source install setup.bash so that our environment is updated with our package that we just built. And then we're going to say ROS2 run mypy package publisher with params. That should fire up the node, and it should print that default message, hello, to the console once every second, because that's how often we said to publish. Let's bring up another terminal. And remember, we are publishing to my topic, so let's just say ROS2 topic echo my topic. When we run that, sure enough, we are subscribing to and printing out that message being sent over to my topic. Let's Control-C to stop both of these. One way to pass in parameters or arguments is to do it from the command line, and that's a great way to test your node to make sure that your parameters are working. We will do that with this ROS2 run mypy package publisher with params. It's the same call we just did. Then we're going to say --ROS -args, and I apologize if the console is not displaying that properly. This is a flag that acts as a separator. Anything before it, any of those flags or parameters, gets passed into our node or our entry point for our application. Any arguments after it get passed into the ROS2 runtime environment, so that framework. And this is where we need to set our parameters. So -p is a parameter that's going to get passed into ROS2. Anything we set here gets passed into that framework, which knows then to update that parameter value when we run our node. We're going to give the parameter name here. So message should line up with what we set in code. If we go back to our code over here, that should line up with this string right here. We're going to use := for assignment. Notice that it's not just equals. And we're going to say hi from ROS2 to change that message. We're also going to set the timer period to 0.5. That's the other parameter. So another -p, timer period, : 0.5. That should have the message being printed more quickly or more often to the screen. So you can see hi from ROS. This message has changed from hello. And if we come over here, push up, we will subscribe to that topic. And you can see indeed that message has changed and it is now being printed more often. So twice per second. Let's press Control-C to stop both of these. Something important to note is that those assignments to those parameters only worked when we first booted up that node. So if we look in our code, we declare the parameters, we say, hey, these parameters exist for this node. We get them once in the constructor. But really on this declare time during that boot process is when those parameters are set. So if you try to change them later, even if you call get parameter later in your code, it's whatever was set at boot time. That's the value that gets set to those parameters. So you can't change them after you've started running your node, at least with what we're doing here. There is a way using callbacks that we can update parameters after the node has started running. But the vast majority of the time, you will do something like this in order to set parameters when you first boot up. But just so you're aware, let's take a look at how we can use callbacks to adjust parameters after the node has started running. We are going to modify our publisher with params node to handle a callback whenever a parameter gets changed during runtime. If you head to the basic concepts parameters for your particular distribution, scroll down and you can get some information on these callbacks. There are three main callbacks you can use. The add preset parameters callback. This happens before setting. This is useful to type check or check for invalid values for your parameters. There is add onset parameters callback. This happens during the setting process. So this is useful to do things like clamp or modify your values if needed. And then there is the add post set parameters callback. This happens after setting the parameter. This is the one we want to use in order to update parameters after they've been set in the internal backend system. Let's go to our code. After we've set to attributes here, I'm going to close this terminal so you can see what I'm doing. I'm going to assign the callback. So we will say self.addPostSetParameters callback. That is a function in the node superclass, and then we're going to pass in the function, which we will write in a moment. We will make this the private post parameters callback inside of our class. The rest of this stays the same. And then after our timer callback within our class here, we will write it. We need to pass in self because this is a member function, and parameters get passed in for us. The parameters come in as an array, so we're just going to loop through all of those and just check to see if the parameter name lines up with the parameters we intend to set. So the parameter should have this name field, and all we're going to do is check against our parameter names. So if the name is equal to message, we will update our message attribute. So to do that, we just call param.value to get the value, and we set it to our message. We'll log that to the screen so you can see what's going on. Then we will check to see if the name is timer period. If so, we will update our member variable, which is timer period. We'll get that from param.value. Again, we will log that to the console. Note that the timer period doesn't automatically reset the timer that we've set up. So if we update that period value, we need to stop the timer and recreate it with this new timer period that we got from the parameter. So to cancel that timer, we just call self.timer. That's the timer we created, that object, and then say .cancel. That's a function in that object. So we recreate it with this self.createTimer. We give it the new period that we just got from the parameter, and we give it the callback that we have been using. It's always a good idea to explicitly catch unknown things that were passed in this case, an unknown parameter. If that parameter doesn't match one of the values we were looking for earlier, message or timer period, we'll just go ahead and issue a warning to the console to say, hey, the user passed in something I don't know what to do with. Let's save that with Control S. Let's go to View, Terminal. I'm going to push up in order to call callcon build, and then packages select my Pi package that builds. Let's go over to our run desktop. This time I'm going to call ROS to run my Pi package, publisher with params, --ROS-args -p for the parameter that we want to pass in. We'll say message, hi from ROS2 again, and we won't update the timer period. So we'll start running that, and you can see it publishing once per second, hi from ROS2. Feel free to double check that by echoing from my topic. You can see it working there. Control C to exit out of that. And we will say ROS2 param list. This gives us a list of parameters inside of our nodes. So you can see our publisher with params node. You can see the various parameters here. We have message and timer period. Those are the ones we created. There's also two other default ones that come with every node. That is start type description service and use sim time. We won't get into those. So we care about message and timer period. Here's how we can set parameters dynamically using the command line. We can say ROS2. We can use the param subtool. And then we say set. We give it the node we want to work with the parameters in. In this case, /publisher with params, we give it the parameter name, message, and then the value we want to set. So we'll change that to greetings. We will run that. It should say set parameter successful. If you come over to our node in the other terminal, you should see that log set message to greetings. And then sure enough, that message has been updated inside of that node. We can update timer period using the same function. In this case, we'll say timer period as the parameter name and give it to the value it expects. So a floating point value, we'll say 0.5, update that. It updates, and sure enough, you can see it publishing more quickly now, twice per second. I'm going to press up, and I'm going to give it a bogus parameter name. Let's say you mistyped this and you just said timer. In fact, you can see it doesn't even get to that else statement. ROS2 simply rejects the parameter because it was not in the list here. Let's go ahead and stop both of those. I showed you how to do this in Python. Now let's recreate this example, but in C++ instead. If you go to the RCL-CPP documentation for your distribution, you can go to C++ API. You can scroll down and learn all about the parameters and their various functions here. We will be using these to declare parameters, get parameters, and set callbacks. Let's go to our code. I'm going to close the terminal for now. Let's close our Python files. We'll go into my CPP package. Let's go into source. As we did before, we're going to copy minimal publisher. So let's copy that. We're going to paste it In order to create a new copy here, let's rename it, and we'll call it publisher with params. Let's close that minimal publisher. First thing we'll do is change the class name to publisher with params. That means we also need to change the constructor call to publisher with params, and we'll change the node name. Before we create our publisher object, let's go ahead and get those parameters. And to do that, we first declare them so that ROS2 or this node knows they exist. It's just declare parameter, just like we saw in Python. We give the parameter a name, in this case, message, and set a default value, in this case, hello. Don't forget the semicolon. We will say timer period and give it a default value. We'll say 1.0. In a moment, we will declare a couple of member variables to hold these parameter values. We'll call the first one message, and we will set it to get parameter, give that function the parameter name, in this case, message, and then we get the value from that. And note that it is strongly typed because this is C++. So instead of just getting a value, we have to say as string and give it the exact type we want. So there are some built-in functions to get specific variable types from those parameters. So as string is the function we will use to get the string, which we will set to message. Notice that this returns a standard library string type. So we need to know that when we go to declare our member variable. We'll do the same thing with timer period. We'll call get parameter. This time we want to say as double for a type of float. And we will set that to timer period, which we will now go declare. So let's scroll down where we declare our member variables. We don't need counter anymore. We're going to get rid of that. And I like to put the parameters up top in front of these. Doesn't matter, just makes them a little easier to read. So we will say standard for the standard library namespace. We'll say this is a type of string, and we'll give it the name message, and this should be lowercase. We will also declare timer period as type double. Let's go up here. We don't need counter anymore. And in the callback, we can get rid of our increment counter. After we get the parameters here, I'm going to go right into declaring a callback so we can update the parameters during runtime. You don't always need this, as I mentioned. A lot of times you just need to pass in parameters when you first boot up the node or call that entry point. That happens a lot with a lot of robotics applications. I just want to set some parameters and say go. But if you need to update those parameters during runtime, then you want to configure this callback or multiple callbacks. Just like we did in Python, we'll use the add post set parameters callback in order to assign a particular callback. We'll use the bind function again that we've been using for handling callbacks. We will say publisher with params. So this particular class, we will use the post parameters callback function that we will write in a moment. We'll pass in this so it knows which object we are referring to, or a particular instance. And we will use placeholders, in this case, just the first placeholder here. We only need one. And I'm going to move these back just to be a little consistent here. And we're going to create a callback handle here. This is useful if you ever need to cancel or modify those callbacks. And we're going to declare that as a member variable after our timer. If you go into RCL-CPP and node interfaces in that namespace, you can find this type of post set parameters callback handle, and we can use this to create a shared pointer of that handle. We will call this variable param_cb handle, which should line up with param_cb handle here. We'll create a publisher object. This is the same, and then we will periodically call our method here. This class name is no longer correct. It should be publisher with params. The callback still exists, and this is not liking the fact that this function doesn't exist yet. Let's go fix that. So in timer callback, this is mostly the same. We want to fill out that message object that we created with this example interface. But instead of this hello world message, we're no longer going to hard code that. We're just going to set it to our member variable message here. It should publish, and it should log it to the console. This stays the same. Then we will create our set parameter function. This is our callback. The parameter in that function needs to be a vector. This is a standard modern C++ library vector. We will use the template RCL-CPP parameter to give it a type. So this is the new and better way to handle arrays, is using these vectors. The type is RCLCPP parameter. That's something built into ROS, a particular type. We can treat them as objects, and we will get an address for that list or vector of parameters. Then we will loop through all of the parameters. Just like we did in Python, this is the C++ way to do a for-in loop. So we will get an address for the individual parameter. In that list of parameters, we'll get those one at a time. We will use this const so we can't modify it, auto so it automatically figures out what type it is, and we can just deal with the parameter inside of our loop. Just like we did in Python, we will check the individual parameter names. We will start with get name and see if it's equal to that message parameter. If so, we will update our message member variable, and we will do that by calling param.asString, just like we saw earlier. Then we will log that to the console using RCLCPP info. We'll say this, get logger. To get that logger, we will say set a string to a string, and then we'll fill out those string placeholders with param get name, and we will need to convert that C++ string type into a C string. So we call the .c_str to convert it to a C string. So that fills out that placeholder. We will do the same with param.asString to get that value, and then also call .cstring. Looks like I have one too many parentheses. We'll get rid of that. If the parameter name is not message, we'll check to see if that name is timer period. If so, we will handle that here. To start, we will update the member variable timer period with the value from the parameter. Then we will log that to the console just like we did earlier with the parameter message. Just like we saw in Python, we need to reset that timer and recreate it in order to update the timer with a new timer period. So we will call timer cancel, and then we will say create wall timer, which comes from the node object. We will give it a duration, which is a standard library type found in the chrono namespace. We'll give it a double type and pass in that timer period that we got from the parameter, and we will bind it to the timer callback just like we did earlier in that constructor. Even though the ROS system won't allow us to set a parameter that's not in that declared list, as we saw when we tried to set timer instead of timer period earlier, I still like to be explicit in my if, else if statements and have this else case. So if we ever get here, it will throw a warning that the parameter is unknown to the system because it was something that wasn't declared. All of our member variables should be set correctly, so we're good to go. We just need to change this shared pointer type to the class name publisher with params. Let's save that. We will go to CMake lists. We need to add that executable, so we'll first call add executable, give it to the target name, publisher with params, tell it where to find that source file, in this case src/publisher with params.cpp, and then we will tell it where to find the dependencies, the libraries we're using within ROS2, so RCLCPP, and those example interfaces, which just includes that string type for publishing those messages. We need to include that executable in our install list. So under trigger points client that we made previously, we'll just write publisher with params, save that with Control S, make sure you've saved your CPP file. Let's go to view, terminal, and we'll say callcon build, packages select my CPP package. That should build your C++ package that we just updated with this new target. Looks like I missed something here. Oh, I know what I did wrong. So let's go up here. When I said update member variable for timer period, instead of logging with a string type here, we should log as a float, and double as a type of float. So let's save that and let's try to compile again. Looks like everything went well. Let's click that, go to our run desktop. And in here, I'm going to say source install setup.bash to make sure ROS2 is now aware of this new executable we just created. Then we will say ROS2 run my CPP package, publisher with params. We will say --ROS-args, like we saw for running our Python node. -p for parameter, message is the name of the parameter. Colon equals to assign something to message, and we will say hi from ROS2. So let's run that. You can see publisher with params. This is our C++ version. It's now publishing hi from ROS2. And in this other console, if we say ROS2 topic, my topic, and I forgot to add echo my topic here, you can see this being published once per second. Let's open up a third terminal, and we will mess with our parameters here. Because we set that callback, We can now update those parameters during runtime. As you can see, with the node still running, we will say ROS2 param set. We will give it the node name, publisher with params, message, which is the parameter name, and then the value for the parameter, which is greetings. We will call that set parameter is successful. You can see our logged message, set message to greetings, and this message is now greetings. It shows up on our echo terminal over here. And we can also update the timer period, set parameter successful. You can see that here. And you'll notice it's a little bit faster. Instead of once per second, it's twice per second. With that, we can press Control-C to shut everything down. I hope this helps you understand how to work with parameters in ROS2. In most cases, you will just need to set parameters on launch and not have to worry about providing callbacks for runtime. But it's good to know how to do that just in case. Next time, we'll see how to create launch files so that you can create different parameter configurations and run multiple nodes with a single command line call.